Function. What is function? A machine, a rule F, which assigns each element of X with a unique element of Y. X and Y are two sets. The word each and unique, these are important. For example, I have this set X and this set Y. You can see here numbers 1, 2, and 3. I write here A, B, and C. Okay? Tell me, is this a relation function or not? Function. Each element is over here, assigned with a unique element over Y. So this relation is a function. Now tell me, if there is another element for left, it is not assigned. Is this relation a function? Why? Because in the definition, each element of this, so this means it is not assigned, so it is not a function. If in a function, we have one element over here, for example, another element, I have D over there. Now, is this a function? Yes. This is a function. If range set element, if without assigning with element in the domain set is there, so no problem for this one. So these are the ladies I told you, and these are the females. These are the female set, and this is the male set. Each lady must be married. Okay, according to the international, whatever the marriage laws are there. Now tell me in this case, if the relation is like this, for example, relation is like this. Now tell me, is this relation a function or not? Is this a function or not? This is a function. Okay, this male has these two domain numbers, two wives here. So it is acceptable. Now, what happens if I join this one with this one? Not a function, because this element have two images over there, two image. This female has two husbands, not allowed. It is not a function. So function definition is very much clear. This rule, marriage rule, is applicable everywhere, and you will have very difficult problems in mathematics, but this rule, when you will apply, you will be able to solve that quickly. And this is not a simple thing. I introduced in 1987, perhaps, when there was a lot of problem with teaching undergraduate students. So that time, and then in master level when I was teaching, 88, 90s, so this rule was very effective in topology even. Topology, you will study, this is related to these functions and all these things are there. So please understand this rule very well. Now here, one function. So in one function, we have this type relationship, one husband, one wife, that's all. Simple rule. So this is the one function. A function f is one function if for all x1, x2 in its domain, fx1 is equal to fx2, if and only if x1 is equal to x2. Understand? What is if and only if? This is a two-way traffic. And if and only if is important part of each definition. No definition is complete if there is no if and if only if. It works in both ways, from this side to this side and this side to this side. If we say two images are equal, the element should be the same. If two images are not equal, then the two elements are not the same, then image will not be equal. So this is a one function. Okay. For example, I have a function f of x is equal to x minus 1 absolute plus 1. F of x is equal to x minus 1 absolute plus 1. Take two numbers. If two numbers are not equal, their range value should also not be equal. I'm taking two numbers here. Take here, for example, I take here 0. So what will happen? 0 minus 1 plus 1 is equal to 1 plus 1 is equal to 2. Is this okay? Here, take another number. Tell me some other number I take, which assert is 2. If I put 2 minus 1, what will be 2 minus 1? 2 minus 1 will give you 1 plus 1 is equal to 2. What is over here? You can see we have two numbers 0, we have one number 2, and their image is what? Image is 2. I mean these two numbers 0 is not equal to 2, but their image are equal. Is this 1-1 function? It's not a 1-1 function. This definition. So if numbers are not equal, their image should also not be equal. Okay, if it is 1-1 function. So here you can say f of, right, like this one. Can you see all of you from this? 0 is not equal to 2, but f of 0 is equal to f of 2. So f is not a 1-1 function. F is not 1-1 function. Any question, please? So if two numbers are different, their image should also be different. If they come the same, it is not 1-1. This is the second definition application. Now, I give you another example. Tell me, f of x is equal to x4 plus 1. Please check it. See, if you are able to find out one reason which is not satisfied, for different numbers, you are not getting the different answers. You're getting the same answer. So that function is not 1-1. Okay? Now, find out, take any two numbers. When power is even, so no, you know negative and positive numbers are very helpful. Same number. Check it please yourself. Good, do it. Write down. Just like a judge in the, write down first and then tell me. Everyone should work. There is no mobile use. Find out two numbers. If you are able to find out two numbers different and they have the same image, function will not be 1-1 function. Let f of, takes easy number, I take 2. This come 2 power 4 plus 1, 16 plus 1, 17. Put here like this, please. F of negative 2. You can take 1 even, no problem. 1 is easy to simplify. I take negative 2 power 4 plus 1 is equal to 16 plus 1, which is 17. Same thing here. 2, negative 2, and image is same 17. See, this diagram can help you to understand. Two numbers have the same image and numbers are different. If numbers are different, image is same, function is not 1, 1. These images should also be different. So you can justify the reason since two is not equal to negative 2, but f of 2 is equal to f of negative 2, which is 17. So f is not a 1, 1 function. Fx is not, put underline, put like this, capital NOT, not 1, 1 function. Give importance to this one. We respect you, not, okay? So underline, important thing we always underline. Great, you understand the idea of this one. One more thing is, I discuss one more thing graphically. For example, I have this graph. All of you know the name of this curve. You know or not? What is the name? X3. Y is equal to X3. So this is an odd function, you know. Power is odd. So this is odd function. So odd functions are symmetrical about the origin. This is blank, this is blank. There is curve, there is curve. About the origin, you can say. And I take another picture here. For example, I take this one. What is the name of this one? Y is equal to x square parabola. I take another picture here. What's the name of this one? Y is x absolute x. If graph is given, how to test? It is 1, 1 function or not? A function is 1 to 1 function when every horizontal line, here we are using a horizontal line test. A horizontal line test intersects the graph at most, this is very important word, at most once. See, horizontal line and this one. Now tell me, I'm drawing this graph. This is the horizontal line. At how many points it is intersecting? 1 point here, 1 point. Anytime this line you take here up over the graph, it is cutting 1 point only. Is this function 1, 1 function or not? Yes, this is 1, 1 function. 1, 1 function. Why? Because horizontal line cuts at 1 point only. Horizontal line cuts. This word is good if you write at most once. At most once. So memorize this word. Very good. Now check about the second one, please. Not a function? Not 1, 1 function. Is this a function? It is a function. Okay, great. Because for function we take the horizontal vertical line. For function we take the vertical line. Vertical line cuts 1, so it is a function. Great. Now we have to check 1, 1. We see when we draw this line, when we draw this line, they are cutting more than 1 point. 1 here and 1 here. It means here you have -1 and here we have 1. -1 and 1 are two different numbers, but heights are same. For example, this height is how much? I take here 2, will be easy. I take 2, this height will be 4, because square comes over for this one. Square of this will come 4 over here. So this height is going to be 4, this height is going to be 4. So two different numbers you are taking, x1, x2, the second definition, they are different, but images are same, heights are same. So is this function 1, 1 or not? Function. When we say function, it means it satisfies all the conditions of the function, you know. Okay, but we are discussing type of a function which is 1, 1 function. For two different values in the domain set should have different range values. So it is not. Okay, write down the reason. Not 1, 1 function. Reason, horizontal line. Cuts at 2 points. In any way you can justify whatever, but logic should be this one. I have seen some paper, this, okay, discuss later. Tell about this one now. Not a 1, 1 function? Okay, great. Why? Because this line cutting more than 1 point, so it is not 1, 1 function. Very good. Horizontal line cuts at 2 points. Okay, great. So you understood the definition of this one. There are two definitions. One definition is this one definition is this one, okay? So this we have applied, we understood this one very well. But this is left, we are taking two images equal, okay, backward direction. We shall see, take 17, 17 and then look back on this one, 2 and negative 2, and then we decide. I'm not erasing it at the moment. Okay. I have this question. Say example 1. F of x is equal to 3x minus 4. See, we were very lucky when we had these questions, x4 and absolute. We are very lucky over here because we know, we are students of mathematics and smart students. We know if this power is even, negative and positive number will give us the same answer. We tried and we were successful. Absolute, we know positive and negative values of x will give us the same answer. Okay, but what about here? Give me two numbers different which give you f of x value different. Can you find out? No. But we are also smart. We know what? What do we know? This is a straight line. This is a straight line. This straight line is like this or like this. No problem. And when we apply the horizontal line over here, cutting 1 point only. So is this a 1, 1 function? Yes, it is. But I'm not allowing you to prove by graphically. No. Mathematically prove it. And here we have to prove for each different number or same number, answer is same. If numbers are different, images are different. And if x values are same, f values are also same. How to do this one? And here we shall apply this definition. Say here, let, write down please here. Let's learn this method. Let fx1 is equal to fx2. We say this is correct. If and only if, this symbol we use for if and only if. And its abbreviation is IFF. Or you can say this one. This is a two-way traffic. And every definition is true in two ways. If definition is not true in two ways, that is incorrect definition. Okay? So this is, So this one, they are equal. We shall prove x1 and x2 are equal. We shall prove this one. If we are able to prove, we shall say this function is 1, 1 function. And you already know from the graph, it will be 1, 1 function. Okay? Let's start this. Replace this x by x1. So this will be 3x1 minus 4 is equal to 3x2 minus 4. I'm going to erase it because you understood it. Add both sides 4, you know this cancels. So 3x1 is equal to 3x2. If and only if. Put this sign over here. Very important. Because if this way it is true, this way also true. And divide both sides by what? 3. X1 is equal to x2. Oh, well done. Got it. Yeah. I cannot. I have a paper. You can clap at least. Okay. Thank you. So you can say here, since fx1 is equal to fx2, if and only if x1 is equal to x2, therefore fx is equal to 3x minus 4 is a 1, 1 function. So this is how to prove a function is 1, 1. Write it down, please, or make a picture. Okay, one more question for you. Example 2. F of x equals x minus 1 radical. Do you know the graph of this function? We know square root function, yeah? Which is an increasing function. Okay. Yeah. All increasing and decreasing functions are 1, 1 functions. What this function is? Okay. So all increasing, decreasing functions are 1, 1. Now tell me over here, how can you check this one? Think about it. Look at the previous solution of the question and write its answer. Same you can say let fx1 equals fx2. Take their images are equal. If images are equal, we have to prove x1 is equal to x2. So then it will be 1, 1. Let me see how many of you are working. Good, very good. Take your time, think, discuss with each other if you want. Very good, very good. Excellent. Excellent. Yes, well done. Many of you are able to do it. Oh, great. Very good. Yes. Taking. Excellent. Okay, students. Oh, I didn't check them. They will mind it. Okay. Great. So you are able to find out either the function is 1, 1 or not. Okay, let's check our answers. I replace the value x1 minus 1 radical, and here I change x1 minus 1 radical. If and only, please. It means if images are equal, this step is equal, this step equal to this go back. Now, squaring both sides. I have seen this morning students are cutting this negative with this negative one. No. Squaring, you take square both sides. So if you square both sides, so what will happen? X1 minus 1 radical, x2 minus 1 radical, their square. And the squares will cancel the radical sign. This cancels to this. And you have x1 minus 1 is equal to x2 minus 1. This cancels, so x1 is equal to x2. Understand? So now you can give the reason. Since this one equal to this, if and only if, the same reason, this reason you can state for this one. Okay? So therefore this function is one function. I write again. Here. Since f of x1, f of x2, if and only if x1 is equal to x2, therefore f of x equals radical x minus 1 is a 1 function. Happy? Yeah. This is how to check a function is 1 or not. 1 is over. Now we have to discuss okay, I give you another example. I don't start inverse function later. One simple question. This is a piecewise function, okay? You will check is the function 1 or not. How many of you don't like piecewise function? Okay, anybody else? Only one student. Doesn't matter. You will like it, inshallah. If x is less than 0, this function is given, and we have to test either this function is 1 or not. How can you check it? This is one function, piecewise function. So can you graph it? I give you a hint, graph it. This is a parabola in this interval, and this is a straight line. Okay, go ahead and please draw this graph. No, x square is always a parabola, but it is only one right side. Please draw the graph first. First draw the graph, then we shall discuss. How to graph it? I take this one easy to make it easy, x and x minus 2. First I take it. And this is less than 0, x bar, y bar. Less than, this is less than x for this line. So take some numbers over here, -1, -2, -3. 0 is not included. So take at 0 value, no problem. When you put 0 over here, this give you 0 minus 2 is equal to -2. Select one more point, take -2. So -2 is equal to -4. Yeah, no problem. We shall show the whole over there. So what is the graph of this one? One point is this one. -4. So what's the first point? 0, -2, and -2, 4, -4. These are the points. Zero, -2. This is the point. Show the hole over here. And -2, -4. -2 is this one, -4 is here. This is the point. Draw this line because this line is less than. So this line will go like this. This is one part of this function. Because we cannot take line on this side because our domain is only this quadrant. Graph parabola. Now you can take the points on the parabola. I take here x and y is equal to 2x squared. Take some points because the parabola is only on this side. We are not taking negative points. Negative points are not required because half of the parabola is there. So take over here. If I take 0, this will give you 0. 1, this will give you 2 times 1 square is equal to 2. 2 will give you 2 times 2 square, give you 8. So take the point here 1, 2. At 0, value is 0 because this point is included. At 1, it is 2, 1, this is 2. At 1, it is 2. And at 2, it is 8. 8 is far from this one somewhere. So I take at 2, 8 somewhere here, okay? Join this one. And this is going infinitely. Is this a function? Because for function, we take the vertical line. It is cutting. And here, this is empty. This point is empty, and this is filled. So only one point comes even over here. So it is a function, first thing is. Second, now we have to check, is this function is 1, 1 or not? Is this 1, 1? This line, this is my horizontal line. How many point cutting? 1, 1, 1. Here, so what you can say, horizontal line test proves this function is a 1, 1 function. Okay? Hence mean always be happy. Hence, fx is 1, 1 function. Horizontal line line test verifies. Okay, students? So this is how you can manage this one. Since horizontal line crosses the graph at one and only one point, so this is, yes, dear.
One of the piecewise is one function and the other one isn't?
One is 1 1 and other one?
Like both of them here is one function, right? Could there be an equation where one is a one function and the other isn't?
No, this is a one function. These are not two functions. Piecewise function. I understand. He says this is 1 1 and this is not 1 1. Is there any example of this type? This is what we want to say. Okay.
The first part was square, and it was a parabola, and the second part was a straight line. It's still gonna be. It's not a one-one function, right?
Are you talking about this one? Something different?
No, it's something different.
I don't know what you're talking then.
No, I'm saying.
I am here.
It's a piecewise function, right? If it was squared, and it was the first part was a parabola, and the second part was a straight line.
No, it will not be. It will not be. It will not be. If its graph is coming over here, for example, and you apply the horizontal line test, would it be a function? No. 1 point will be here, 1 point will be here. So why he is putting the restriction over here? If its one part come over this side, and you apply the this one vertical line test, it will not be a function then. If it is not a function, then there is no question of 1 1 function. So he is imposing the restriction. First, it should be a function. It is a function. Okay. Try it, please. Make a question and come to me and we shall discuss about it. Okay. Thank you very much. Thank you for joining. See you inshallah next time.